function yesterday that I have given? 200 into s plus 2 s into s square plus 10s plus 100. Correct? Hello. Please respond.
Yes,
please respond. One of you, those who have a better network, please respond. Okay, now we know. Okay, is this in pole zero form or is it in time constant form? Because you're asked to plot Bode plot. When you're asked to plot Bode plot, we are supposed to convert the transfer function into time constant form. Am I correct?
it's in pole zero form, sir.
No. Is it necessary to convert it into time constant form, or is it okay with this form?
We have to convert, sir.
Why we have to convert? Okay, I think we already discussed it. Now we should just convert this into time constant form. Time constant form is nothing but 1 plus s tau form. So shall I write it as 200 into, I'll take out 2 outside from this. Will it become 1 plus s by 2?
Yes, sir.
And here it is, yes, you have a quadratic term. You have a quadratic term. In this case, is it in the form of s square plus 2 zeta omega ns plus omega n square?
Yes, sir.
It's actually in this form. So when it is actually in this form, this is like a pole zero form. So I need to convert this into time constant form. Matlab, so I will take out omega n square as a common factor. Exactly here, omega n square is 100.
The video is stuck, sir.
Video is stuck.
No, it's
Now it's moving because I have a reference there. So I will take out 100. So is it s square by 100 plus 10 by 100s plus 1?
yes, sir.
So this is my transfer function. I'll just take out this. This will become 2. Is the now transfer function 4 into 1 plus 0.5s divided by s into s square by 100 plus s by 10 plus 1. Am I correct?
Yes, sir.
So now we know, okay, how to write the individual. Suppose if you are asked to write the table, if I are asked to write the table, is it like, okay, there is a serial number, okay, or the term. So the term, cutoff frequency, slope, and individual slope. Am I correct? Sorry, this is individual
Yes, sir,
slope,
exactly.
this is resultant slope. So now
Yes, sir.
I will write it as 4 by s. That is your first term.
Yes, sir.
So cutoff frequency, there is no such cutoff frequency. It is minus 20 per decade, and this is minus 20. Am I correct?
Yes, sir.
Next you have 1 plus 0.5 s. Will it have a cutoff frequency 2 radian per second?
Yes, sir.
Then is it plus 20? Is it 0
Yes, sir.
dB resultant?
Yes, sir.
Then we have a term something like this: 1 over s square by 100 plus s by 10 plus 1. Correct?
Yes, sir.
Now, what is the cutoff frequency and what is its slope? So, is point of discussion now, because now this is your quadratic term. If such quadratic term is there, because we know, okay, what is the individual plot for this 4 by s, or suppose if you have 1 by s. So, what is its term? What is the slope?
Minus 20 dB, sir.
No. How do you represent this 1 over s? If it is 0
It's
dB,
just a slope, sir.
so is it a slope of, okay, sorry, this is minus 20 per decade.
Yes, sir.
Is it a minus 20 dB per decade line passing
Yes,
through
sir.
0 dB at 1 radian per second?
Exactly, sir.
Correct?
Yes, sir.
How about this? This
That will be
is it 0 dB line
plus 20 dB.
till 2 and then plus 20 dB per decade after 2 radian per second.
Yes, sir.
Correct?
Yes, sir.
Now, especially for this, that is, you have 1 over s square plus 100 plus s by 10 plus 1. Out of
Yes,
which,
sir.
okay, this we actually got it from this s square plus 2 zeta omega ns plus omega n square term, no?
Yes,
This
sir.
was actually s square plus 10s plus 100. So out
Yes,
of
sir.
which, what was omega n? Was it 10?
Yes,
If
sir.
you equate these two coefficients of your s,
Yes, sir.
so omega n is equal to 10. So for such a term, for a pole which is having complex poles, So the representation is, so till omega n. So if it is 0 dB, till omega n, the representation of this term, that is it actually 1 over s square plus 10s plus 100?
Yes, sir.
So the representation of this is till omega n, it is of 0 dB.
Yes, sir.
Slope is also 0 dB, magnet is also 0 dB per, because this is 0 dB, 0 dB per decade is the slope.
Yes, sir.
Afterwards, it decays with a slope of minus
Minus
40 dB per decade.
It's quadratic equations.
This is minus 40 per decade after omega n. After omega n. So coming
Yes,
to
sir.
this, what is omega n here?
100, sir.
Omega n square is 100, so omega n is 10.
It means 10, 10. Okay, sir.
So what is the integer slope?
It's minus 4.
Minus 40. So then
Yes,
is it
sir.
not minus 40 dB per decade?
It is, sir.
Correct. So what
Yes,
is
sir.
MEAO now? Magnitude at the origin. Is it not 20 log K minus of
Yes, sir.
20 log omega,
It will be, sir.
which is 0.1?
Yes, sir.
So is it not 20 log 4 minus of 20 log 0.1? Suppose if you are taking origin frequency is 0.1 radian per second.
Yes, sir. 32.04.
So meaning to say, suppose if I write this as omega, this is 0.1. How much? 32 point?
It starts from 32.04.
Okay, 32 dB. What is the initial slope?
First minus 20.
Minus 20. Till where?
Up to 2.
To 2. So I will write
Yes,
this
sir.
as your 0 dB line. This is
Yes,
0.1.
sir.
Will it come till here? So this is assume that this
Yes,
is
sir.
2 radian per second. What is the slope? Minus 20 dB per decade. Correct?
Exactly. Yes, sir.
Then
Yes, sir.
afterwards,
Then it has to go 0 till 10.
so shall I write it as 0 till 10?
Yes, sir.
Then
Yeah, then it will go at minus 40 dB per decade.
940 dB. Correct?
Yes, sir.
Is this fine?
Yes, sir.
Okay. This is the magnitude plot. Done?
Yes, sir.
Next, what is the phase equation?
There we have
For
the-
phase equation, it is not necessary that you should have it in time constant form or pole zero form. Both will be same. Am I correct?
Yes, sir.
Because
Always.
whether you have it as s plus 2 or 1 plus s by 2, it is the same thing.
Yes, sir.
Correct? Okay, now what we'll do is we shall take it as s plus 2, of course 200 divided by s into s square plus 10s plus 100. Correct?
Yes, sir.
Let
Yes,
us
sir.
replace s by j omega. Will it be j omega plus 2 into 200 divided by j omega? Is it not minus omega square plus 10 j omega plus 100?
Yes, sir.
Can I now find the phase equation? So what is the phase 1 is due to 1 over j omega, and next is due to 2 plus j omega, and next one is due to 1
Yes, sir.
over 100 minus omega square plus j 10 omega. These are the
Yes,
phase
sir.
terms.
No, they are, sir.
So what is the phase contribution by this?
Tan inverse of 1 by s, right? 290 degrees, sir.
Because real part is 0.
Yes, sir. Minus
So it is minus 90. Irrespective of anything, if there is 1 over s, you can simply write the phase contributed, that is minus 90 degree.
Yes, sir.
Why? It's like, okay, 0 plus so and so.
Yes, sir.
What is 1 over 0 plus so and so? So it is minus tan inverse of omega by 0. Omega
Yes,
by
sir.
0 is infinity. Tan inverse of
Infinity.
infinity is
90 degrees.
minus 90.
Yes, sir.
Then, of course, minus because it's in the denominator. Then is it
Yes.
not tan inverse of omega by 2?
Yes, sir.
Next, what is this?
Minus.
Is it, okay, sorry, I'll write it as minus tan inverse of, what is imaginary tan? Is it not 10 omega
Yes, sir. It is.
by 100 minus of omega square?
Yes, sir.
Am I correct?
Yes, sir.
So the phase equation is this. So phi is equal to minus 90 plus of tan inverse of omega by 2 minus tan inverse of 10 omega by 100 minus omega square. Fine.
Yes, sir.
So suppose you just, okay, this is not the phase equation for all values of omega.
Yes, sir.
Now why it is not the same value for all values? Because so far when we discussed phase equation, we didn't had different phase equation for a single transfer function. We had only single transfer function for a single equation,
Yes,
correct?
sir. Yes,
Now
sir.
what I'm saying is this is not the only phase equation for all values of omega. So this is valid
Okay.
for omega less than 10.
Yes, sir.
Why it is less than 10? Suppose him that if omega is equal to 10, what happens to this?
That will become infinity or
Will it
again
become
90
minus
degree.
90 degree?
Yes, sir.
So for values of omega greater than 10, greater than 10.
Yes, sir.
So assume that you have omega is equal to some 8.
Yes, sir.
What will be the real
Right.
and imaginary terms? Can you just tell me here what will be the real and imaginary terms here? If omega is equal to 8, so let us take this. Is it 100 minus 64 plus of j 84? Sorry, 80.
Yes, sir.
So what will be this? Is it what is this? 26 or no 36? 36? 36 plus j80. Am I correct?
Yes, sir.
So this is the pole
Okay.
position. Is the pole position?
Yes, sir. It is.
Suppose
At
if I,
36. Okay.
am I correct?
Yes, sir.
So it is assume that this is 36, this is 86. Is this your pole position?
Yes, sir.
So
Okay.
phase angle is this. Correct?
Yes, sir.
So you can see this is, what is the value of omega? It is 8.
Yes, sir.
If omega increases, does the pole actually moving like this?
Yes, sir. It is.
If omega becomes 10, what happens to this?
At whole term 90 degree.
No,
It will
no, no.
become zero, sir.
Will this become
Zero,
0?
sir. Yes, sir.
What will happen to your imaginary term?
It will be on origin, sir.
Origin.
Uh,
Will it not
Lies
come
on
here at
the
10?
plane.
Will it not
Yes,
come
sir.
at J10?
Yes, sir. J10.
Does it mean that it actually travels like this?
Yes, sir. It will become oscillatory.
If the value of omega less than 8, will it actually go like this?
Yes, sir.
So whatever phase angle that you are finding is actually this angle. Correct?
Yes, sir.
Which is nothing but tan inverse of 10 by so and so. I'll get it.
Yes, sir.
Now, can somebody find if omega is equal to 8, what is this? Okay, if it is 8, what is tan inverse of how much is this? Tan inverse of 80 by 64. How much is that? 80 by 64?
80 by 64. Sir, 51.34.
This is 51.34 degrees.
Yes, sir.
Assume that omega is equal to 12.
Yes, sir.
If omega becomes 12, as per our movement, does, okay, as you do this, as omega becomes 12, is it not actually 1 over 100 minus 144 plus j 120?
Yes, sir.
Correct? Then
Yes,
what
sir.
is the pole position? So is the
Minus
pole
44.
position minus 44 plus of j 120?
Yes, sir.
Where do you represent this? Can you see the real part is negative?
Yes, sir.
So shall I? This is minus 44 and this is 16. Okay, 124 somewhere here. Sorry,
Yes, sir.
this is your point? Somewhere here.
Yes, sir.
What is this phase angle? How do you find the phase angle here? The phase angle now is, what is the phase
From
angle? It's actually this
90
angle.
degree plus that angle. Yes,
It's
sir.
actually this angle.
Yes, sir.
Suppose what I'll do, I will just make this, okay, will it become tan inverse of 1 120 divided by minus 44. Correct?
Yes, sir.
Can you find this angle? Because minus of this. Okay, just find what is this angle.
Minus 88.09.
What is this minus 88 something? Is because we are actually looking at this point. Am I correct?
Yes, sir. Yes, sir.
Now, intuitively, the poles are actually moving from first quadrant to second quadrant.
Yes, sir, they are.
So, for till values of omega less than 10, I was getting exactly same angles.
Yes, sir.
Even for omega is equal to 10, I
One
was
second.
getting exactly 90 degree. When the value of omega
Yes,
exceeds omega square, that is this 100. This 100, actually
Yes,
the actual pole comes here. Actual pole comes here. What should
Yes,
actually
sir.
happen to your phase angle? Phase angle should become 90 plus something.
Yes, sir.
Correct?
But it's negative.
What's happening
Yes,
here?
sir.
You're totally getting a different answer.
Yes, sir.
Why it is happening so is because the real part, whatever you are getting, has become negative, and imaginary part is still positive.
Yes,
I'm
sir.
actually supposed to find this angle. Since I'm supposed to find this angle, when I actually do it using this, like okay, tan inverse of what? Where is that? I wrote it as tan inverse of minus. This is tan inverse of minus. Sorry, 120 divided by minus 44 is not giving me more than 90 degree. Am I getting it? I'm not getting more than 90
No,
degree.
sir.
But
Yes, sir.
actually, I should get more than 90 degree.
Yes, sir. It has to be.
What to do now? I need to make a correction to this phase angle. Only this part.
Yes, sir.
So this equation is valid for all values of omega less than or equal to. Make it equal to also. If it is equal, this will become minus 90 degree. It is still fine.
Yes, sir.
So for values of omega greater than 10, I can't use the same equation. Let me just slightly. So
Modify it.
is the angle to be found is this from here
Yes,
to here?
sir.
So instead
Yes,
of doing that, shall I do this? This minus
Yes,
this.
sir. 180 minus that angle.
So what I'll do now, for values of omega greater than 10, the phase equation is minus 90
Minus
as it
90.
is plus tan
Tan
inverse
inverse
of
of
omega
by
by 2 minus of
minus
180 minus tan inverse of 10 omega by omega square minus 100.
Okay, yes, sir.
So now if you substitute, so what is the value of omega you have taken? Omega was 12 no?
Yes, sir.
Shall we take it as, is it now minus 180 minus of tan inverse of 12 by 44?
Yes,
Is this
sir.
angle, what is this angle now? I am just
Uh,
looking at this magnitude. Forget about this
Yes, sir.
negative.
Yes, it is 164.
One?
Minus 164.
No, forget about this. Is it 164 degree?
164. Yes, sir.
Meaning,
Okay,
you're
getting
actually
it.
measuring this. So 164
Yes, sir.
is after 90.
Yes, sir.
It is not like, okay, minus 88 something. Correct?
Got it, sir.
So, whenever you have a quadratic equation, we will going to have two phase equations.
Yes, sir.
One for values of omega less than or equal to omega n.
Yes, sir.
Next one, you have to make a small correction in this term wherever you have a quadratic equation, phase equation. It is 180 minus of this. So make sure that this is never becoming negative. How do you make sure that this is never becoming negative? Make sure that omega square is more than 100.
Yes, sir. Okay.
Done?
Yes,
So
sir.
now we can actually find the equation, or we can actually find the phase values.
Omega G. Omega PC, sir.
Okay, now it is 0. For 0, what is the phase angle? Minus 90 degree.
Yes, sir.
For infinity, for omega is equal to infinity, is it not minus 90 degree? Is it not plus 90
Yes, sir.
degree? Minus of 180 minus, what is this? This is 90 degree.
90 degrees. Yes, sir.
This will go off and you end up with minus 90.
90 degrees.
Is it again minus 90 degree?
Yes, sir.
In between that will have change.
Okay. Yes, sir.
So here till omega equal to 10, you use the earlier equation. After omega is equal to 10, you have to use this equation.
Yes, sir.
Okay, fine. Okay,
Yes, sir.
let us go to this particular. Can we find omega GC now?
Yes, sir.
What is
But
omega?
for finding
Yeah,
omega GC, which equation we have to go, sir?
same equation. Omega GC is just under root, no?
Uh,
Omega GC
yes, sir.
will not have much impact.
So for finding omega PC, while we substitute for minus 180 degree and
Now,
found.
where there you have to be careful. Now, suppose if omega GC comes to be greater than 10,
Okay. Yes,
then you
sir.
have to use this equation because you are trying to find the phase at omega GC which is greater than 10. You need to use the phase equation which is corresponding to more than 10 radian per second.
Yes, sir.
If omega GC is less than 10, then it is a different ballgame. Then you have to use the other equation, the previous equation, this one.
Yes, sir.
Okay.
Yes, sir.
I don't know. Okay, how many of you got this? Okay, let me just try to. Can we actually find out okay what is omega GC coming for this? So shall I maybe let me just try to use 20 sim and try to find out what is. Or can you just find out okay what is you feed this equation, try to find out what is phase for different values of omega less than 10. So we have one phase equation, phase is equal to minus 90 degree minus plus tan inverse of 0.5 omega minus tan inverse of 10 omega by 100 minus omega square. Same is minus 90 degree plus tan inverse of 0.5 omega minus of 180 minus tan inverse of 10 omega square minus 100. Correct?
Yes, sir.
What is the phase equation? The term was 200 s plus 2 divided by s into s square plus what is that? 10s plus 100. Correct?
Yes,
Uh,
sir.
how do I do this now? Shall I write it as okay 200 under root of 2 square plus omega square by s is omega under root of omega mm, is it like okay what will be the real term? Is it 100 minus omega square whole square plus of 10 omega whole square? Am I correct?
Yes,
Magnitude.
sir. Only right. Only real part is.
Here that question of negative will not come because whatever the value of omega is, even if the value of omega is more than 100, sorry, if omega square is more than 100, you have minus of that square, it will become positive.
Yes,
Correct?
sir.
So you don't have
Yes, sir.
different magnitude equation. You have a single magnitude equation irrespective of the value of omega. If omega is equal to 10, if omega is equal to less than 10, more than 10, it is the same. If it is omega is equal to 10, then this will become 0. You have only this.
Yes, sir.
Getting the point? This is pure math. There is nothing, no control stuff here. So shall we find what is omega GC? How do you find omega GC? Is this equation fine? So what you have now here is 200 j omega plus 2. This is j omega. And what is this? This is 10 j omega plus 100 minus omega square. Correct?
Yes, sir.
You have the real term, imaginary term. So real term square plus of imaginary term square under root. So here you have the same thing.
Yes, sir.
Can we find omega GC? Equate this to 1, you'll get omega GC. Can you do that?
Yes, sir.
Do it now. I'll equate this to this. Is it 200 into under root of, sorry, under root of 4 plus alpha a whole square close divided by double open, okay, alpha a into under root of okay, 100 minus alpha a square close square of that whole square of that. I will have opened one more. I'll just do that.
15.237.
Okay, let me just verify. Can somebody second it?
Yes, sir. 15.2.
Done. Let me verify. Let me just get the same answer. Just to have confidence. 10 alpha, sorry, 10 alpha a whole square close. I don't know how many closes I have to make. I think I'm there. Shift cal. Okay, omega GC is how much? 15 point?
237, sir.
23 radian per second. Okay, maybe let me just wait for this to come. Okay, now, okay, cannot solve. What happened to this? Okay, I think most of you might have got this answer. It is 15.23. This is omega GC. How do you find omega PC now? What is omega PC now?
Choose second equation.
What is omega PC now? Or what is the definition of omega PC?
It's a frequency when the phase is minus 180 degrees.
Will at any point of time does the phase crosses minus 180 degree? See here. Is the phase contributed by this is minus 90?
Yes, sir.
The maximum phase. So what is the maximum phase contributed by this?
It's
plus 90.
Yes, sir.
What is the maximum this may contribute? Minus 180.
Yes, sir.
Correct? So this is minus 90, this is minus 180, this is 90. So you have minus 90, plus 90 and minus 180.
Minus 180. Yes, sir.
Now it will reach minus 180 only when omega is equal to infinite.
No, that's impossible, yes, sir.
So omega PC is infinite radian per second. No need to find. Your calci will say I can't solve.
Yes, sir.
Because this is theoretically speaking, alpha is at omega is equal to infinity only, it will going to give minus 180 degree.
Yes, sir.
Correct? So at omega is equal to infinite radian per second, what is the magnitude of this? Will it be minus infinity?
Yes, sir, of course.
Then what is gain margin?
Plus infinity.
Infinity.
Is it not infinite dBs?
Yes, sir.
Which is minus of minus?
Yes, sir.
Okay. So system is absolutely stable.
Absolutely stable.
The point is, what is phase margin? Phase margin can never be infinite.
Yes, sir.
What is phase margin now? It is 180
minus
minus phase at omega GC.
Yes, sir. 15
So since it is 15 point something, which is more than 10, you have to use this equation.
Yes, sir.
You have to use this equation to find phase. 180 minus this phase will give you phase margin. Can you do that now? Feed this equation, substitute omega as 15.23.
Minus 90 plus tan inverse of.
Just put omega as alpha a so that it will be easy, so that you can say cal 15.23.
Yes, sir. Minus tan inverse of. Minus 138.38.
So it is is equal to omega pc is minus 138.
Yes, sir.
Correct?
138.38. Yes,
Okay,
sir.
then what is phase margin? Is it not 180 degree minus of 138? Is it not
Yes, sir.
42 degrees?
Yes, sir.
So phase margin is 42 degree. So phase margin is 42 degree. What is gain margin? Infinite.
It's plus infinity.
Shall we just do the same thing and verify it in
The last
20
one.
sim? 20 sim. I'm just opening 20 sim. Let me share it.
Yes, sir.
Submodel linear system. Let me share it. Where do I share? Share content. Where is the content to be shared? 27. Okay, now it's visible. Let me go to pole zeros. Where are the poles? Poles are at 0. Am I correct?
Yes, sir. One is at
One
0.
of the pole is at 0. Where is the second pole? Okay, there are actually two poles. Can you
Yes,
actually
sir.
find the real and imaginary parts of that? A square plus 10s plus 100.
Yes, sir.
Find the roots of it so that I can edit that. Roots of a square 10s plus 100. 1 over a
It is
square.
minus 5 plus or minus 8.66.
Minus 5 plus or minus 8 point?
66.
8.66. Okay, done. It's applied. Okay.
A 0 at 2, right?
Okay, there is a 0 at.
Minus.
Okay, there is a 0 at minus 2.
Yes.
Correct? Okay, let us see. What is the system gain?
Right.
Now we can see
200.
system gain, it should be 4.
Oh, it's completely.
Otherwise, root locus gain is 200. See now,
Yes, sir.
the moment I select root locus gain and edit as 200, can you see automatically it becomes 4?
Yes, sir.
Can you see it's becoming 4?
Yes, sir. Got
Why
it.
it is 4.00 something? Because we have truncated this 0 position, sorry, pole position,
Yes,
8.66. So if you write all the terms, okay, you'll get it 4.000 something. Correct?
Yes, sir.
Now, are you
Yes,
getting
sir.
now, okay, how why it is 20, why it is 4, and why it is 200?
Yes, sir.
So root locus gain is the gain that is given when the transfer function is in pole 0 form.
Yes, sir.
That's
Sir,
what we
it's
have.
not visible clearly.
Which one? Root that 20 sigma.
Yes, sir.
What can I do? That is a smaller window. Okay. Is this not visible? Okay, now
It's too blurred, sir.
since it is small in size, okay, let us try to find out pole 0 positions. Can you see these are the
Yes,
pole
sir.
0 positions? One is at origin, other is at minus 2, and you have it at what, minus 5 and plus or minus j 8.66. Done?
Yes, sir. Yes, sir.
Looking at this, suppose if you draw the
Yes,
root
sir.
locus, draw the root locus, is the system absolutely stable?
Yes, sir. It will go plus infinity, minus infinity.
See now, can you see it? It's here. There is an asymptote here. It just actually goes.
Not visible, sir.
Can't you at least see this pole
Sir,
positions?
it's just. Now it's visible, yes, sir.
Okay, this is where it's going. Of course, since it is truncated at 10. Okay, let me just do this change. I'll change the x-axis to, instead of 10, I'll make it manual. I'll make it up to minus 100 to minus 100 to plus 100, just for clarity.
Yes, sir.
See now, can you make out this? Hello.
So it is a green screen. I think.
Green screen.
No.
Okay, it takes some time.
Yes,
Can you
sir.
see
Now
the
it-
system is absolutely stable?
Yes, sir.
Asymptote is somewhere around minus 4. That's why it is going like this.
Yes, sir.
So here in this root locus, you will not get the phase margin.
Yes, sir. It just shows us where it is going. How it is
Yeah.
going.
So if you want to know the phase margin, of course, we will take this phase margin and try to do some analysis in LMRF. So
Yes,
why
sir.
I'm not doing LMRF in last 3 days is because I need this basic to do the next topic in LMRS, which is the design of what is that, op-amp amplifiers. So in op-amp amplifiers, we take phase margin and then from there we start developing the things. Correct? So
Yes,
that's
sir.
the reason, okay, why I didn't start LMRF this week. So unless you know what is phase margin, gain margin, there is no point in teaching that amplifier design. So now here we are not getting what is gain margin, phase margin. Of course, gain margin can be easily found out that, okay, for any values of k, system is not becoming unstable, means gain margin is infinity.
Yes, sir.
So
That is possible.
let us go to this board A and find out what is. See here, this is a plot.
Yes, sir.
See here, can you see this is going positive?
Yes,
Not,
sir.
not positive. Is it actually going from minus 90 degree? Is it actually going slightly more positive towards, okay, minus 80, minus 50 going?
Yes, sir.
And then again it comes down.
Yes, sir.
Why it is slightly becoming positive? In the sense, okay, from minus 90, why it is becoming up to minus 50? Because of a 0.
Yes, sir.
0 will
It
contribute
has to
positive
move this
angle,
direction. Yes, sir.
because a 0 will actually give positive phase.
Yes, sir. It has to.
So now try to find out what is.
The phase and gain margin.
Can you see the phase margin 41 degree?
Yes, sir.
Did we got the same thing? 42 degree
Yes, sir.
something?
Almost, yes, sir.
41.55. Can you see the what is that?
Frequency.
is
Omega.
15 point. This is what, omega?
GC.
GC. This is
Yes, sir.
15.23.
Yes,
24
sir.
radian per second, exactly what we got it using your equations. Because equation value and this 20 sim values are perfectly matching, because this is not asymptotic, this is a real plot.
Yes, sir.
Correct?
Yes, sir.
So what is that we are trying to learn today is, if there is a quadratic term, how to proceed.
Yes,
First
sir.
and foremost thing is that whatever the transfer function, whatever format that is given, first you bring it to time constant form.
Yes,
So
sir.
time constant form in case of quadratic is, it should be the omega n square term should be 1.
Yes, sir.
See here, this one, this should become 1.
Yes, sir.
So you try to take out omega n square as common factor, you'll get it as 1. So that will be the time constant form.
Yes, sir.
Then whatever the constant value you will get, so that will be k. From then you start.
Yes, sir.
So then
We'll have two phase equations.
before that, now what is the cutoff frequency of this? Cutoff frequency of quadratic term is what?
It's minus 40 degrees.
No. Cutoff frequency. Cutoff frequency of any quadratic term is
the
omega
WN, sir.
n,
N.
not W,
Yes, sir.
omega.
Yes, sir.
It is omega n, which is the natural frequency of oscillation for that system. It is omega n, and the slope is, after omega n, it is minus 40 dB per decade. This is the slope.
Yes, sir.
This is after omega n. Correct?
Yes, sir.
So that's how we went. And for the phase, we need to be bit careful. For values of omega less than or equal to omega n, it is a normal equation.
Yes, sir.
If it is more than omega n, then we may have to make slight alteration in this. Exactly 180, the equation remains the same thing. This term is replaced by 180 minus tan inverse of 10 omega by omega square minus 10.
Yes,
That's
sir.
what we had. That's what we had it here. Yeah.
Yep.
This
Got
this
it.
is this is the change that you have to make. And you can see since the value of omega GC you got is 15.23, we did use a phase equation which is for omega greater than 10 because your
Yes,
omega
sir.
GC is more than 10. So
Yes, sir.
since we substituted that value of omega PC over here, we got it as 42 degrees, which is verified in your 20 sim also 41.83 degrees as also. Correct?
Yes, sir.
So this is how you can able to do the things. Done?
Yes, sir. Very interesting.
Shall we
Yes,
do
sir.
one more? What is did we had one more quadratic equation, something like that?
Fifth question, yes, sir.
Shall we do it? Now we started a bit late. It's time we can just go with that also. It's already there in time constant form. Am I correct?
Yes, sir.
What is that equation? I have the equation like. Okay, let me write it. Any questions here? Anybody? Could you able to get? Can you just put in the chat box? Are you fine with this? 10 out of 10, 8 out of 10, 3 out of 10, 0 out of 10. Just put in the chat box. Two things, sir. How to write the magnitude plot for a quadratic term and how to write the phase equation. And of course, when you're actually finding omega GC, writing this is also an important thing. So how do you write this? How do you write this? Put in the chat box quickly. So your response. Meanwhile, I'll be just writing the equation. I'm just looking for your response in the chat box about understanding quadratic term representation in Vodafone. 0.05s divided by s into 1 plus 0.1 s into 1 plus 0.02 s multiplied by s by 200. I think it is not s by 200. Yeah, s by 200 whole square plus 0.02 s divided by 200 plus 1 plus 1. Correct?
So screen is not.
Is it not visible?
No, it's okay, sir.
Okay.
Suddenly,
That okay, sir. Correct.
Again, it went off.
Went up. Screen is
It's
going
a
up.
full green screen, but
Oh. But here, anyhow, you people have
yeah,
that
now it's
equation.
fine, sir. Now it's fine, sir.
Okay. I don't know what is the network issue. No, this is a problem from the textbook. You just try to find out. ಅದೆಲ್ಲ ಒಂದು ಯಾವ ನೋಡಿ ಮೇಡಮ್ ಹೇಳ್ತೀನಿ ನಾನು ನಿಮ್ಗೆ ಕಳಿಸ್ತಾ ಓಕೆ ಕಳಿಸ್ತೀನಿ ಕೊಡಕ್ಕೆ ರೆಡಿ ಆಗಲಿ ತಪ್ಪದಿಲ್ವಲ್ಲ ಮೇಡಮ್ ಕಳಿಸ್ತಾ where are the poles now?
So,
So I think I have a issue with this term. So I'm just looking at the textbook itself.
200.
It is s by 200 whole square is there. I'm just wondering whether omega square is 200 or omega n square is 200. I think omega n itself is 200.
Yes, sir. Omega in itself is given to
Omega n is 200. Can we write it as s square plus because I just want to verify it using 20 sim so that I can write the pole positions. Is it actually 0.02s
Yes, sir.
plus 200?
200.
Or what is this into
Yes, sir.
200? 0.02 into 200, is it 4?
Yes, sir.
Is it this? S square plus 4s plus 200 whole square?
Yes, sir.
Correct?
Yes, sir.
Okay, then where are the poles now?
1 plus 10.
Correct? What is 0.05? Is it minus 20?
Yes, sir.
And here, where is what are the roots of this? Roots of this?
Second, sir. We have at 50 also, right? So minus 50 and
Oh, okay, this is minus 50. Let me write it.
equation.
Okay, let me edit this.
One
One of you,
I was about to check, but
200. Sir, it is
just a minute. Let me edit the poles and zeros. Let me delete all of them. Okay, one of them is at origin. Next is at minus 10. Am I correct?
yes, sir.
Next is
minus
at
50.
minus 50. And the other one, the complex?
0. Sir, that is minus 2 plus or minus 14. Right?
Yeah, 14.
Yes, sir.
Correct? It is minus 2. Is it 14?
Yes, sir.
How about 0?
0 is at minus 20.
0 is at minus 20.
But
Yes, sir.
Okay, I will say it okay. This is done. Let us see the pole 0 plots. Oh, I'm already getting it. This is how the root locus looks like. Can you see system is conditionally stable?
Yes, sir. Conditionally stable.
So for okay, let me just edit that system gain or the root locus gain. How much
Yes,
is
sir,
the
this one.
system gain that we didn't edit?
Root locus
Actually,
gain is 10.
no, whatever that is given is system gain. Correct?
The in time polar point, sir.
If it is there in time constant form, it is system gain.
It's direct system gain. Yes, sir.
System gain. Now it is now 50.
Sir, 10 also.
Hey, it is 50, no? Is it 10? It is 50.
Just
Yes, sir.
which property are you using?
Correct?
Yes, sir.
Close
Yes,
this.
sir.
Naturally, looking at this, what is the root locus gain? Root locus gain is 22,550,000.
Yes, sir.
So naturally, system has to be unstable
Yes, sir.
because
Too much of
let me just try to track the. Can you see if I increase the value? Can you see the roots are here now?
Yes, sir.
It's already unstable. What is the system gain? What is the root locus gain? It's actually 0.123.
Yes, sir.
For k value is equal to something like 2 lakh, it has to be unstable.
Yes, sir.
GMPM has to be negative. Shall we do that?
Yes, sir.
So what do you mean by GMPM? I'll go here. Can you see GMA is 0.1 and PMA is minus 112 degrees?
Yes, sir.
Correct?
Yes, sir.
What is gain margin in terms of dBs now?
So
Gain margin is written as 0.1127. Correct?
Yes, sir. It is.
At omega GC is equal to 12.86 radian per second. What is PM is equal to minus 112 degrees. It's at omega PC is equal to 21.32 radian per second. Correct?
Yes, sir. It is.
Okay, let me just show that. These are the values. So this is ratio. What is 20 log of that? 20 log of
Minus
0.1127. Okay, it is minus 18.96 dBs.
96.
That is at what frequency? 12.8. Can you see it's
Yes,
almost
sir.
there? Can it's almost minus 19 degree here? Minus 19 dB. This is 0
Yes,
dB.
sir. It is.
This is around 20.
Yes, sir.
Okay.
Near to be.
Can you see initially slope is negative and then it becomes slightly 0 dB and then it comes down drastically down.
Correct, that one is
Yes, sir.
What is the final slope?
It's minus 40 dB.
Is it or minus 60 dB per decade?
Second. Minus 48 dB per octave I got it.
Octave.
Plot ಮಾಡಬೇಕು.
First it is minus 20, then it is another minus 20, then it is okay. Oh, this one. What is this? These are two,
Minus
no?
86.
These are 200.
Yes, sir.
First it is minus 20, then it is first it is minus. Let me just write the phases. Initial phase is minus 20. Next comes 10. No,
Yes, sir.
there's a polar 10. This is also minus 20, so that it is minus 40 now.
40. Yes,
And
sir.
then comes this 50.
Yes,
Sorry,
sir.
this is 20.
At
Correct.
20 plus 20.
So then will it become minus 20 now?
Yes, sir.
Then minus 20. Then will it become minus 40? Then it
Yes, sir.
is minus 80.
Yes, sir.
Finally,
Yes, sir.
will it actually go like this? First it is this,
Yes, sir.
this,
Yes, sir.
minus 20,
Again,
minus 40,
Yes, sir.
minus
Then
20,
minus 20.
minus
Then
40.
minus 40. Then minus
So,
50.
so no, okay, minus 40 and minus 80. So this happens at 10.
One is at yes, sir.
This happens at 50. This happens at sorry, this is at 20.
Yes, sir.
Can you get 20? The slope actually reduces,
Yes, sir.
and then this is at
And also happens at 50. Sir.
50, and these are 200.
Yes, sir.
This is how the slope goes. You cannot make out such a drastic change here.
Yes, sir.
This is happening so, but this is not asymptotic one, no? You cannot make out that.
Yes, sir.
So if you write asymptotic one, you'll certainly get it. This type of change in slope.
Yes, sir.
Okay. Hopefully, I'll do one more class on maybe two more class on root locus. Sorry, Bode plot. Then we'll move on to next week. Maybe it will be full of LMRF, so that the stuff whatever that we have learnt in CS in EC can be just used in the design of op-amp two-stage amplifiers. So we'll be just of course interesting to see how does this phase margin will be effective over there. Okay, then thank you.
Sure, sir. Thank you.